Super excited to be here at PyData Berlin 2025. Yeah, super excited. All right, thanks for hyping me up. Cool. My name is Marco Gorelli, here to talk to you about universal data frame support with Narwhals. Now, before we begin, this talk is going to touch on both some technical parts and some community parts. We're going to talk about lots of data frame technologies, SQL, Pandas, Polars, lots more. But we're also going to tell a story about how we can come together as a community to overcome fragmentation and, via unification and standardization, solve real problems. Yeah, fragmentation. I feel like that's a topic you might be able to relate to here in Germany. Feels like a hot topic, and perhaps nowhere is fragmentation of German society more evident than in the north versus south split of Aldi supermarkets. But I don't want to give an overly fragmented image of Germany. Germany is actually fairly unified under several other aspects. For example, if there's one thing that unifies north versus south, east, west, young, old, everybody, if everyone can agree on something, it's that there is no better pastime than to complain about Deutsche Bahn. Cool, thanks for, wow. Hey there. I noticed you arrived slightly late. Did you by any chance travel here with Deutsche Bahn? No, I'm sorry, that's enough complaining about Deutsche Bahn. I'm worried that otherwise someone from Deutsche Bahn is going to follow me home, catch me, and then have a stern warning. Or rather, I would be worried about them catching me if they weren't always delayed. OK, yeah, that's enough. I actually love trains, love Deutsche Bahn. A friend of mine, Maren, gave a really good talk at PyCon Germany about what they're doing at Deutsche Bahn. Really cool, and there was lots of mentions about polars. So with that, let's focus a bit. Let's get back to the presentation. It's not all jokes. So I understand that most of you have probably never heard about Narwhals, so I'm going to start by getting you motivated. Going to start with a little comparison of life before Narwhals versus life after Narwhals. Once we're all hyped up, we're going to learn a bit about how to use Narwhals. We'll learn about how to do basic things, lazy versus eager execution, row ordering, indexing, very fun topic. And then, because this is not just any topic, this is not just any conference, this is PyData Berlin. So we need to go deeper. So we're going to talk about the relational model, SQL, why deprecation cycles are, in my humble opinion, awful, and some Narwhals-specific static typing concepts. After that, we do need to talk about community, so we're going to talk about the people behind the project, a short history, how you, and you, all of you can get involved, and finally, I'll share some lessons learned from managing, building, and interacting with the community. Finally, all of my talks end in exactly the same way. That is to say, with some even split between engaging Q&A and awkward silence. If you'd like to contribute to the engaging Q&A part, there was the QR code earlier for where to submit questions. Right, let's talk about life before Narwhals. So I'd like to start with a little excerpt of a blog post published by Plotly earlier this year, in which they show the difference of how long it takes to make different kinds of plots with different kinds of data frames. So the data frames stay fixed. The plot kinds stay fixed. The versions of all libraries, like everything stays fixed. The only thing that's changing is the version of Plotly. We're comparing Plotly version 5 versus Plotly version 6. So plotting a Pandas data frame in Plotly version 6 stays about the same, maybe gets a little bit faster. But plotting a Polars data frame or plotting a PyArrow table, those become a lot faster. What happened? Well, the answer is that Narwhals happened. Narwhals is a lightweight compatibility layer between data frames, and this is what Plotly used to get those speedups for Polars and others. Because before, in Plotly version 5, they were just converting any input to Pandas. Whereas with Plotly version 6, they could keep all the computation native to all of the user's data frames by using Narwhals as a lightweight compatibility layer. Now, Narwhals is a tool for tool builders. It provides you with a single unified API with which you can support Pandas, Polars, PyArrow, DuckDB, PySpark, and more. It's used by several major open source libraries like Altair, Bokeh, Marimo, Plotly, Shiny, and other fun ones. Full list on the README. And it comes with 0 required dependencies, some very strong, stable API promises, and is fully statically typed. Now, before we go any further, anyone here having an affair today? No, just checking. OK, now there's nothing wrong with using Pandas. The issue, however, is when we force the entire ecosystem to go through Pandas. It's a bit of a missed opportunity, because it means that we give up on the benefits of lazy execution, it means that we might give up on the benefits of GPU acceleration, and it means requiring everyone to have some extra heavy dependencies. The Narwhals way, on the other hand, means meeting the user where they are. If the user passes in Polars, then use Polars. If the user passes in QDF, then use QDF, and similarly for PyArrow, DuckDB, and others. Now, it is possible to do this without Narwhals. You just need to write a lot of if-then statements. In fact, even these if-then statements are not enough, because within the if pandas block, you would need if it's pandas and it's pandas less than version 2, do this, else if it's pandas between 2 and 2.1, do this, and you quickly give yourself a headache trying to test all of this out. So instead of giving yourself a headache, accept the fact that we gave ourselves a headache and use the fruit of our labor, which is this single unified API. Now, I'm making a big deal about no dependencies, so let's dive a little bit deeper on why dependencies are so bad. Now, when you work in Python, at some point, you inevitably encounter what's informally known as dependency hell, in which you cannot upgrade your environment because different tools pin different packages to incompatible versions. It's super annoying. It means that you might not be able to support new versions of Python. So that's why in Narwhals, from day one, we've been very strict about this. 0 required dependencies, extremely lightweight. No special exception is special enough. Right, now that we're all feeling hyped about Narwhals, let's learn a little bit about how to use it. So first of all, how do you write a data frame agnostic function? You just need to follow 3 simple steps. So step number 1 is you're going to call from native on the user's input. Then step number 2, you're going to express your logic using the Narwhals API. Now, the keen observer who might be familiar with Polars will notice that this is very similar to the Polars API. In fact, it's just a subset of the Polars API. And then finally, you return the object to the user by calling .toNative on the result. And if you do this, then as far as the user is concerned, Narwhals does not even exist. The user just sees that if they pass in a Pandas data frame, they get a Pandas data frame out. If they pass in a Polars data frame, they get a Polars data frame out. If they pass in a DuckDB PyRelation, they get a DuckDB PyRelation out, and so on. In terms of what's supported, you'll find most of the fundamental data frame operations should be there. Joins, aggregations, selecting, dropping, filtering. There should be string operations as well, accessible with the .str namespace. Temporal operations, accessible with the .dt namespace, as well as different kinds of joins. Let's have a little bit of audience interaction. I'll read out the joins, and when you hear your favorite type of join being called out, please give us a cheer. So left join. OK. Outer join. OK, not so many. Inner. All right. The underappreciated semi. Yeah, told you it was underappreciated. OK, anti. So you clapped for anti, but not for semi? Fair enough. And finally, one of my personal favorites, join as of, in which you join based on closest matches rather than exact conditions. Now, truth be told, there is actually another kind of join, but you probably think about it so little, you didn't even notice it was missing. And the reason it's missing is because nobody's asked for it. Instead, we are much more focused on letting you express yourself. So when I started Narwhals, it was somewhat controversial to follow the Polars API. Some people were saying, oh, but Pandas is so much more popular, use the Pandas API, use eager execution, use series, use square brackets and all of that. And I was like, I kind of agree with both Polars and Dr. Dre on this one. Like, it's important that you can express yourself. Now, expressions, they are inherently lazy, and so they allow for certain kinds of optimizations. Furthermore, they are not tied to any particular data frame, meaning that they can be reused across contexts. And finally, in my opinion, they are more readable. I realize that this last point is purely subjective, but that's the good thing about starting your own project. If you have a subjective opinion, you can just follow it without having to justify it to anyone. But it's not just Polars, Dr. Dre, and the Narwhals community who agree on the importance of expressing yourself, because Pandas is also joining the party. About 3 weeks ago, I made a pull request to Pandas to add pd.col, and so introduce this expressions syntax to Pandas as well. And to my great surprise, 2 weeks ago, they actually merged it. So in Pandas 3, expression syntax is coming. You heard it here first at PyData Berlin 2025. All right. Something else I like about expressions is that they are chainable. Like if the output of an expression is always just a column, then it means you can keep on applying expression operations one after the other. And if you really want to dive into expressions, I recommend going to the talk in room B5 later by Jeroen Jensen about Polars expressions. But before we get there, just to elaborate on what I mean, you can select a column, you can apply some operation on it, you can keep on applying operations, abs, round, clip, dot rolling mean, you can keep on compounding them. Mind you, I don't know why I'm explaining this to you here in Germany. I think you already have a natural affinity for combining things together to make a very long compound thing, which is how you end up with monstrosities such as this one. I refuse to believe that this is a real word. I think it's just a practical joke that you're playing to make German harder to learn for us foreigners. Anyway, we've talked about the Polars API, but there's something missing, isn't there? Like Polars does not have an index, which plays a central role in Pandas. So how do we deal with the index in Narwhals? Now, in Pandas, not only do you have labeled columns, you also have labeled rows. For example, check out this beautiful data frame over here. We've got 2 columns called nsongs and awesomeness, and our rows are called belugas, narwhals, and dolphins, and we're just capturing some very objective information about them. Now, in Pandas, all data frame operations align on the index, which in theory is powerful. In theory. In practice, I've never inherited a Pandas codebase from someone which was not absolutely littered with .resetIndex drop equals true absolutely everywhere. The reason for this is that it's fairly unintuitive sometimes. If you're not careful, Pandas is going to do things which you did not expect. For example, if you create a data frame, sort it by a column, and then maybe try inserting a new column, you might expect that the new column is going to be inserted with values 7, 8, 9, but actually, it'll get inserted with values 9, 8, 7. And that's because Pandas creates a default index. When you sort the rows, the index also gets sorted, and then Pandas aligns on the index. This is why most people slap resetIndex drop equals true all over the place. I think the intended solution would be to set the index in the series when you create it, but in practice, everybody is slapping resetIndex all over the place. So what do we do in Narwhals? In Narwhals, just like in Polars, there is no concept of an index. So what do? We align values positionally, just like how Polars and PyArrow and DuckDB and the others would do it, but in order to appease Pandas users who really care about the index, when we return the final result to the user, we make sure to preserve the index of the leftmost object. And as a consequence of this, fun fact, when Plotly started using Narwhals, 4 historic bugs got fixed for free. This was, fairly rewarding to me. The Pandas index was doing things that were unexpected to the Plotly developers, and when Narwhals started doing its own indexing alignment behavior, then it actually behaved in the way that the Plotly devs had intended it to work when they wrote it. So there you go, 4 historic bugs fixed for free. As a consequence of not doing resetIndex all of the time, we also find that the overhead becomes so low that it's often negative. So this is why when Plotly switched from version 5 to version 6 using Narwhals, the overhead for Pandas was so low it was practically negative, and even for Pandas, plots got faster. And of course, for Polars and PyArrow, they got even faster. Now, Pandas, Polars, PyArrow, we're talking about eager execution here, so let's go on to the next big topic, lazy execution. We can broadly categorize data frames as being either eager or lazy. There's various ways of doing this categorization, but the one that we care about the most for the purposes of Narwhals has to do with row order. So in the eager case, we assume that all data frames are in memory and have a well-defined row order. Whereas for lazy cases, we make no such assumptions. And in particular, we treat row order as undefined. So asking what's the first row, what's the second row, these questions are just not well posed. So what's the consequence of this when we do order-dependent operations like cumulative sum? So in the eager case, you just progressively sum values in the order in which they appear. For example, if you need to take the cumulative sum of the values 1, 4, 2, and 5, you would just get 1, 5, 7, 12. You just do it in the order in which the data appears. If you try to do this with a Narwhals lazy frame, however, you'll get an error telling you that you can't do it, because row order is just not assumed. So how can you do a cumulative sum in a Narwhals lazy frame? Well, the answer is to not make it dependent on physical row order, but instead give the name of a column which orders your data. Now, this is not a syntax that we invented. This is perfectly valid Polars syntax, and this is what I mean when I say that Narwhals is a subset of the Polars API. So if you write it in Narwhals, it should also be valid Polars, but the reverse is not true. We introduce some extra restrictions, and these restrictions are what allow Narwhals to then support different kinds of backends like PySpark, DuckDB, and other SQL-like data frames, which make different assumptions compared to eager ones like Pandas and PyArrow. Speaking of SQL, let's go a little bit deeper into the relational model, which is what SQL databases approximate. How close is Polars actually to the relational model? Now, in the relational model, row order is not assumed. They define a table to be an unordered set of tuples. Now, set implies that everything needs to be unique, whereas data frames typically allow for duplicate rows, so there is some departure from the set part. On the unordered part, Polars preserves order in many operations, so yeah, it gives some extra guarantees. But I think one part that's not appreciated enough is that Polars allows you to operate on each column independently. Now, this is really powerful, and it's so powerful that if you're not careful, you might end up with rows that were not originally part of your data frame. For example, if we start with the data frame of Frozen the musical data, we have a name, Elsa, Anna, and Olaf. We have their voices, we have their roles. So if we assume that it's not well defined which row comes first, okay, we don't know if Elsa, Anna, and Olaf come first, but we know that Olaf is always a tenor with a supporting role. However, if you were to select the columns voice and role and drop nulls, then because Polars lets you operate on each column independently, you can end up with a data frame like that one in the bottom, in which mezzo-soprano, which is Anna's voice, gets matched with Elsa's role. That's not a combination of attributes which appeared in your original data frame. So I don't think that SQL gives you a way to do this. Now, I'm sure that someone can find a way to do this in SQL by, I don't know, making a row index and joining with itself and doing something very complicated. But just within a select statement, it's not possible, as far as I'm aware, it's not possible to do this in SQL. So if this is valid Polars API, how do we deal with this in Narwhals when we want to translate the Polars API to SQL-like data frames? Well, the answer is, again, we make the distinction between eager and lazy, and in the lazy case, we introduce some restrictions. In the eager case, we say, yeah, okay, go mad, do whatever the backend allows you to do, operate on columns independently. If you end up with something unintuitive like this, then maybe it's a user error. We don't take responsibility. But in the lazy API, we introduce some more restrictions, because we need you to write code which is going to be agnostic across SQL-like backends. And in particular, we impose that expressions are not allowed to change order or to change length. If you try using that expression with a Narwhals lazy frame, you'll get an invalid operation error. It'll tell you that it's not allowed unless the length-changing expression is followed by an aggregation, because in that case, it would not break the relational model, and SQL would be absolutely fine with it. Speaking of SQL, as it turns out, you can use Narwhals to generate SQL programmatically in Python from the Pandas API. You can just write your Pandas syntax using Narwhals and using DuckDB as the backend, and then, so long as at the end, after you've done from native, you do .SQL query, well, there you go. You've just translated your Pandas code to SQL. This was a quite fun. It's not what we set out to do with the project, but it's something we noticed at some point, like, hey, we can do this. That's pretty cool. I'm not very good at writing SQL by hand myself, but I think I know a thing or two about Pandas, so I was very happy to discover this. Right, let's talk about something controversial. Static typing. Any fans of static typing in the house tonight? All right, lots of people. Nice. I wasn't expecting so much enthusiasm. Nice. It's certainly a different landscape in Python compared to how it was a few years ago. Anecdotally, it seems to me like that people who got into Python in the early days feel like static typing is a bit of a betrayal of what Python originally stood for. But I'm a big fan of static typing, and I'd like to make the case for why I think static typing is so awesome. So it helps prevent bugs before they happen. I've had a couple of occasions when this has actually happened to me. So if anyone says that static typing does not prevent actual bugs, well, case closed, you're wrong. Second, it improves with the developer experience. I'll show you an example later, but it means that your IDE, so your interactive developer environment, will be able to offer you more helpful autocomplete, and it'll show you doc strings more accurately and more easily. Furthermore, I've had several Narwhals contributors say that all of the typing all over the place made it easier for them to understand the code base and to get started. And we all want talented contributors when we make an open source project, don't we? And finally, in each new version of Python, the static types just keep getting better. They're just always adding new nice features. Type checkers are getting better. So it's an exciting space to be in. I recommend embracing it. On the good developer experience, just to show you an example, if you start writing Narwhals code, even just like in Vim, like NeoVim, if you've set up an LSP, then it'll be able to offer you autocompletion. Similarly in VS Code and PyCharm, like if you've got static typing, this works so much better than if you don't. Furthermore, because we make heavy use of generics within Narwhals, then your IDE will know that if you've got a dataframe agnostic function, if you put dataframe x in out, you will also get dataframe x. Sorry, if you put dataframe x in, you will also get dataframe x out. So if you're trying to transition a code base from being tied to one particular dataframe towards making it dataframe agnostic, then Narwhals will help you be backwards compatible. Speaking of backwards compatibility, how far can we take this thorny concept? Now, people sometimes complain when libraries make changes. It can break your code. It means you can't just update. But if a library never changes anything, then that's also bad. It means you can be stuck with some bad design decisions, confusing API. I'm not necessarily referring to any particular library here, but come to your own conclusions. I'll just say that never changing and being overly tied to backwards compatibility is not necessarily a very good solution. The solution that a lot of packages come up with is to go through deprecation cycles, but I'm not a huge fan of those either. The idea behind deprecation cycles is that at some point you decide that some function is bad, and then you start emitting a warning if people use it. And then 1 year later, instead of emitting a warning, you emit an error, but by then people should have listened to their warnings, so the error shouldn't affect anyone. Yeah, right. In practice, people often ignore their warnings unless they are loud errors. They put off addressing deprecation warnings as they're not urgent, and it becomes harder to keep dependencies in sync. So what do we do in Narwhals? The solution is that we've got different namespaces. So we've got a main Narwhals namespace in which we might make deprecations and we might change the API. Sorry, not sorry. But we've also got a stable API in which the promise we make is that code you've written today should keep on working 10 years from now, barring upstream changes which we can have no influence over. But the API itself should stay stable there. This is not something we invented. This is really just inspired by the concept of additions in the most beloved programming language of all, Rust. And this is what has allowed us to make deprecations which have had no effect on Altair, Plotly, and Marimo users, because these libraries are all using the stable API in Narwhals. Right, let's talk about community. Who's behind Narwhals? So I started the project on Valentine's Day in 2024 with the best initial commit message ever, WIP. And about an hour later, I started getting a little bit excited, like, getting there, kept on hacking it. And then eventually that afternoon, I got really excited. I can see that I was really excited because I wrote getting there with 3 exclamation marks. And that was the last commit of the day before I went to dinner with the person who, at the time, was my girlfriend, and who now is my wife. Hey. Yeah, so after Valentine's Day, kept on hacking on it when I had time. And to my great surprise, in a few months, Francesco came onto the scene and drove for Scikit-Lego to start using Narwhals. And he then got so addicted to Narwhals that he probably implemented 80% of the functions in the project. Maron also got on board fairly early, especially improving lots of the examples in the docs and implementing some cool things. In August, it started to be used by Altair, especially thanks to the push from someone called Dan. And then in January, Plotly started using it, later Bokeh. Like, it really just exploded much faster than any of us could have predicted. And the project is completely community-driven. Like, there's no Narwhals company, there's no Narwhals product we're trying to sell you. Nonetheless, I'm grateful to my company for providing me with some unfunded time to work on it. But it's really been a community project. We've had over 100 contributors. We've got regular community calls and Discord. While we're doing shout-outs, let's also shout out to Inessa for having set up the community calls and Discord, which have been really good for engaging the community. If you're wondering about the project philosophy, then the simplest way that you can find out about it is after you've pip-installed Narwhals to write from Narwhals import this, and this will print out the Zen of Narwhals, which some people have called a poem. I think that's a bit generous, but nonetheless, it prints out some words which tell a little bit of story and some lessons from the project. One that I kind of want to call attention to is the last line, which is our code is not irreplaceable. I generally feel like a lot of developers get overly attached to what they write, and they don't like the fact that sometimes better solutions come across, and they find it hard to let go of things that they've written. And I think if you come to terms with the fact that your code is not irreplaceable early on, you're going to have a better experience working as a developer. Right, let's share some tips for growing a community. So, contributing guide so that people know how to get started, code of conduct. I think this is not good advice. This is just non-negotiable. Like, it's not enough to grow a community, but it's just like the baseline. Once you've got those in place, then having a low-pressure communication channel like Discord means that people can chat with each other. They can just ask low-pressure questions in a way that doesn't feel as daunting as having to post on GitHub or on a mailing list where things are just going to live forever. Second, open community calls. Like, we have community calls in Narwhals which are open to absolutely anyone to join. In a year and a half of doing this, we haven't had any disruptive experiences. If we were to, well, that's why we've got a code of conduct. I think, yeah, the potential downsides of having open community calls are fairly low. Just be prepared to deal with them. Make sure you've got your moderator hat on if necessary, but the potential upsides of being open to the whole community are really quite notable. Did anyone watch the Python documentary that came out recently? It's pretty good. Not as many hands as I might have been hoping for, but in that documentary, Guido van Rossum says that he started Python and he was open to receiving suggestions from anyone, but ultimately, in the early days, he was the one driving the decisions. I think that's a good way to start a project. Like, be open to the community, receive suggestions, but don't democratize decision-making too early. Like, early on, it's good if there's somebody with clear ideas for the direction of the project who's able to drive it forwards. And then later, once it's become established, maybe think about setting up a steering council and all of that fun stuff. I think Python continues to be a huge success after Guido has stepped down. Like, as I was saying earlier, the latest versions of Python just keep getting better and better. So I think we can learn a lot from the good things that they are doing. Something else I wanted to touch on was, yeah, share your roadmap and priorities, but also involve people. So if people are making good contributions, then I suggest being fairly liberal with giving them some permissions to review pull requests. Like, put some guardrails on. Don't let people merge straight to main. Certainly don't let people force push to main. Require approvals before merging pull requests. But once you put some guardrails in place, the chances of things going wrong or of people abusing their powers are fairly limited. And if somebody does merge something that wasn't ready, you can always revert it. And the upsides that come from making people feel involved greatly outweigh whatever potential downside there is. The same cannot be said about release permissions, though. I think a couple of years ago, the open source world was shook by the XZ storm, in which a malicious actor had spent years trying to get the trust of a community so that then they could get malicious code out into the world. So for releases, I recommend being extremely picky. So only give release permissions to people who you know in person, who you've met multiple times, and who you know exactly who they are. If all you know about a person is their online avatar, then you should not trust them with such elevated permissions. Right, I want to share one more piece of advice, and that is the best kind of development style in the world. Because we've heard about test-driven development. Documentation-driven development does not get nearly enough attention, but I think it's maybe arguably even better. But there is no comparison to the best development style in the world, and that is spite-driven development. Because when you are writing a project, there's often a bit of a difference between what's useful to the community and what's interesting to you. Like, you might be interested in improving your intermediate representations, rewriting things, refactoring endlessly. But in Narwhals, what I think has been more useful to the community has been the pain points that other people did not want to address, because, yeah, they are kind of painful to work on. Things like unified data type handling, interoperability with NumPy, and being able to do data frame operations without the Pandas index constantly getting in the way. I was fairly frustrated with a few people, and a lot of the motivation for me to prioritize what was useful as opposed to what's interesting to me came from the desire to take revenge and spite. Was this very petty of me? Yeah, maybe. And maybe that's all that I should say about this slide. Let's move on. So what comes next in Narwhals? So first of all, we want to make Narwhals pluggable so that people can make their own Narwhals plugins for whatever new libraries that they want. It's not feasible for everything to be within Narwhals itself. I've heard somebody who wants to make a Narwhals plugin for Xarray, somebody else for Daft, and lots of other libraries are coming on. Somebody might want to make a Narwhals plugin for their closed source data frame, which would not be feasible for us to do in Narwhals. So we want to give people the power to make their own Narwhals plugins. We also want to let you serialize and deserialize expressions without having to go through Pickle. Pickle has a lot of issues, so if we can avoid Pickle, it's probably better. Finally, we want to make the API more expressified, so it feels closer to the Polar's native experience, and we want more libraries to use Narwhals. If anyone here maintains a data frame consuming library and would like help in making it Narwhalified, then please feel free to reach out to any of us here. We would be more than happy to have a discussion about it and get Narwhals into your library. Right, now, before opening up the floor to questions from the audience, I always like to be a couple of steps ahead of my audience. So let's address a couple of things before they inevitably get brought up in the Q&A. So first of all, there is this XKCD comic about standards. There are two people looking at a situation in which there are 14 competing standards, and they say, 14, ridiculous. We need to develop one universal standard that covers everybody's use cases. And soon, there are 15 competing standards. Now, I was aware of this comic when I started Narwhals. And my response is that Narwhals is not trying to cover everyone's use cases. Instead, we have some use cases in mind. We are trying to do those extremely well, at least as best as we can, but we are not trying to solve everyone's problems. We are not trying to be the last dataframe API you'll ever need to learn. So I recommend following the Unix philosophy here. Like, do one thing, try to do that one thing as best as you can. Don't try to do everything. The other thing that people often bring up is, wait a sec, wasn't Arrow meant to solve this? Why do we need Narwhals? And Arrow and Narwhals, they are both addressing problems with dataframe interoperability, but they are tackling different problems within the same space. I think the projects are orthogonal in this respect. Arrow unifies data interchange and memory layout, whereas Narwhals unifies APIs for dataframe operations. And in fact, it's possible to use them both together. This is what Vega Fusion does, and they use Narwhals for dataframe agnostic code, and the Arrow C interface for accessing underlying data in a dataframe agnostic manner. Right, so in confusion, what have we talked about today? So we've talked about how Narwhals is a tool for tool builders. It's widely adopted in the data ecosystem and is used by Altair, Plotly, Marimo, and many more libraries. It allows you to write dataframe agnostic code, which supports Pandas, PyArrow, Polars, PySpark, DuckDB, and many more through a single unified API. My hope is that with Narwhals, we can address fragmentation within the data science ecosystem, and that one day we can achieve unification. And maybe we can aim for a level of unification not seen since German people's agreement on complaining about Deutsche Bahn. Thanks, everybody. Happy to take some questions. Thank you. Cool, thanks, everyone. You're amazing. All right. You want a joke? Oh, no. A joke about Deutsche Bahn? I think I've told enough about Deutsche Bahn.
No? Yes? OK.
Hey.
If Pandas was not around anymore, would there be a need for Narwhals?
I could not understand anything. Sorry, it's like it was echoing really strongly.
If Pandas was not around anymore, would there be need for Narwhals?
I'm sorry, I really cannot understand anything. I don't know if it's just where I'm standing.
Come close.
OK, thanks.
If Pandas was not there anymore, would there be need for Narwhals?
If Pandas was not there anymore, if you wanted to write dataframe agnostic code which can still support the other libraries, like PyArrow, Polars, and so on, then I think you would still benefit from having a unified dataframe interface. If, on the other hand, if Pandas was to be gone and everybody just wanted to use Polars for everything, then maybe you wouldn't need Narwhals. But as much as I love Polars, I kind of hope that that doesn't happen. I think Polars solves a lot, but maybe it doesn't solve absolutely everything. And so I hope that people can continue making dataframe agnostic applications which are not tied to any particular dataframe, but instead allow to meet the users where they are and allow users to bring their own dataframe. OK, what's next? Let's see how many we can get through.
There are only 3 here.
All right, should be able to do that quite easily.
Yeah. Dataframe have different capabilities. Does Narwhals API support using whatever function that specific dataframe offers while handling the conversion between the scenes, behind the scenes?
So, OK, first I want to make sure I understand the premise of the question, because you're talking about conversions behind the scenes. Narwhals is only converting the API rather than dataframes themselves. So there are also some functions specific for converting between data frames, but most of the data frame agnostic functions, they are not going to convert data. They're going to keep everything native to the original data frame. As for user-defined functions, if that's what the question was about, then for that, you would typically do toNative, have a little block with your library-specific user-defined function, and then go back to the Narwhals layer. But maybe we can brainstorm on making that a bit more easy and a bit more unified.
Some of our friend is asking, tell us more about what was driving your Spy-driven development.
You might have to get me drunk tonight in the pub to hear more about that story.
All right. Do you have an opinion on polars with columns? Did you reproduce this API? I wish it was mutate like rdplyr.
OK, well, thank you very much, Jeroen, for asking this. Wasn't you? Definitely not. For asking these amazing questions. I kind of like fluent APIs that have with statements. So I'm kind of partial to with columns. And if typing an underscore is so inconvenient, maybe you might want to consider remapping it to another key, or just using your auto-completion from your IDE. Just start typing WIT, and that will probably come down in the suggestions. Should polars change with columns now? Probably not. If polars was restarted, would it be better to use something other than with columns, like mutate or assign? Maybe. Maybe it would kind of be nice to have a verb, but yeah, can't go back in time to change polars. And I think for Narwhals, it's better to just follow the polars API rather than introduce a 15th competing standard.
Right. Our most received question. What's the difference between Narwhals and IBIS?
Could you summarize the differences between Narwhals and IBIS? Oh, OK. I should probably have prepared for this. Maybe we've got something. Oh, right. So how does Narwhals differ from IBIS? So yeah, IBIS provides a Pythonic front end to various SQL engines, as well as to some functions within polars. And it doesn't have to be Narwhals versus IBIS, because as of pull request number 2000, yes, this person got number 2000, Narwhals actually supports IBIS. So if you were thinking of using IBIS with the DuckDB backend in a new project, you could just use Narwhals, and then you still get access to the DuckDB backend natively, but also you can use IBIS as your backend and get access to IBIS's other backends as well. So it doesn't have to be one versus the other. Narwhals supports IBIS now. And yeah, let's come together as a community and do good things together.
If we have more time, how does the dataframe landscape looks like in the 2077?
OK, well, thank you, Andy and Laura, for asking this question. In 2077, well, for one thing, I think with columns is still probably going to be there. I think Deutsche Bahn is probably still going to be using polars to analyze railway data. I don't know if that will help to address some of the things that people frequently complain about. I expect that yeah, I don't know. I'd like to think that there will be a greater separation between eager and lazy use cases, whereas now a lot of the libraries that support data frames, they tend to be tied to eager execution and don't really make much use of laziness. So I hope that people can lean in more to that.
And stable V2 will be there. How to convince my team to use polars? We're stuck with pandas.
Right. So you know that meme of like Kim Jong-un like pointing, you know, there's somebody programming and like there's various officials like intimidating someone. I think that's the kind of situation in which you probably want to use pandas when you're starting a new project. Other than that, I think that polars really covers virtually all the ground. And it's just like so much faster, so much more reliable, and it'll lead you to much more robust solutions. Now, if anyone feels like I was being a bit harsh on pandas there, you know how like in comedy people are allowed to make groups that they're part of? So I was part of the Pandas core development team, so I feel like that gives me a free pass to criticize pandas.
5 more minutes and 2 more questions. What's your take on data frame schema validation in function signature via Pandera? I use it with Pandas. Is Narwhals compatible with that?
They've got an issue about using Narwhals in Pandera, so if you upvote the issue, then maybe we can peer pressure them into using Narwhals.
Last one. Serialization of expression. Why is it useful?
I don't know, but a few people ask for it, and it's kind of interesting to work on. And now we've kind of proved the usefulness of it. Maybe can I just come back to the question about how to convince my team to use polars? I would say that some people will say that performance isn't an issue like for them. You know, they're dealing with small data sets, and so Pandas is fine. So in response to that, first of all, I'll say that performance isn't an issue until it is. Like at some point, you are going to get enough data that performance is going to be an issue. And second, as we've seen with the 4 historic bugs in Plotly, which got automatically fixed for free when they moved over to a more polars-like API, yeah, it's kind of hard to use Pandas correctly. Some parts of it are very unintuitive. And if you want robust pipelines, maybe consider using a more modern data frame library. Are you waving at me, telling me 5 minutes, or do you have a question? All right.
Yeah, now it works. Yeah, so the adoption rate is quite impressive, as you just said, for Plotly. Do you know how much effort it was for them to adopt to Narwhals?
Well, maybe this is a question for Francesco.
I don't know, 40 hours of development and a few meetings with them, but it went a long way. Like it was us developing the code and the migration, basically. Yeah. I mean, we learn a lot of stuff and we improve a lot of stuff in Narwhals as well. So it was a good opportunity for us to learn. We had some overhead that we had to take care of, and yeah, it was a great experience.
Yeah, can second that. Shout out to Plotly if they're listening.
I think that's it. Give another round of applause for Marco.
All right, thank you. Very kind of you. Thanks, everyone. You're the best. And